Hi, my name is Radu Ionescu and today I'm going to present our paper FreSaDa, a French satire data set for cross-domain satire detection. This is joint work with Adrian Gabriel Chifru from Aix-Marseille University. I will start by introducing the motivation of our work and our contributions. Then I will present related satire corpora. Next, we will go through the details of our novel corpus, FreSaDa, the baseline methods, and our unsupervised domain adaptation method. Approaching the end, we will present empirical results, discuss some discriminative features, and draw our conclusions. Let's start with the motivation and our contributions. Satire detection is a necessary step towards building conversational systems and robots capable of understanding and producing natural language. Inaccurate detection of satire or irony might lead to wrong actions taken by such conversational system or robots when they literally interpret satirical comments of humans as commands, thus taking unwanted actions. Despite the importance of the task, there is a lack of resources for French. To this end, we introduce FreSaDa, a novel French satire dataset of news articles collected from regular and satirical publication sources, which allows us to perform cross-source satire detection in various settings. We also propose a novel, effective, and generic unsupervised domain adaptation method which brings significant improvements for two baselines, one based on string kernels using character n-grams and the other based on camembert embeddings. Let's look at the related satire datasets. Satire detection has been studied in various languages, such as English, German, Arabic, Turkish, and French. There are only 4 corpora having more than 10,000 samples, and FreSaDa is the 5th one. With respect to Guibon et al., our dataset is larger by an order of magnitude. Different from Guibon et al. And Liu et al., in our approach, the training and testing examples are issued from different publication sources. This enables us to perform a more realistic evaluation, preventing machine learning models from taking decisions based on features specific to the publication source, such as the style of writers for certain publication sources. Let's go into details about our corpus. We divide the 11,570 examples into training, validation, and test using stratified sampling. Our dataset is balanced, containing 5,648 regular news and 5,922 satirical news. We consider two possible tasks on FreSaDa. First, cross-domain binary classification of full news articles into regular versus satirical examples. And cross-domain binary classification of headlines or titles into regular versus satirical examples. We consider two baseline methods. First, we consider an approach based on low-level features captured by string kernels. String kernels measure the similarity of strings by counting the number of contiguous subsequences or n-grams of characters that two strings have in common. Hence, text documents can be interpreted simply as strings. The advantages of this approach are as follows. First, we do not need any text tokenization. We also achieve language independence, which means that the approach can be applied to any language, only retraining is necessary. Here is how this approach works. Given two strings s and t over an alphabet sigma and the n-gram length n equals 2, we construct the hash maps s and t containing key value pairs such that the key represents an n-gram and the value is the number of occurrences of the respective n-gram in S and T. Using this definition, we obtain the following hash maps. The histogram intersection string kernel is the sum over all bigrams of the minimum between the number of occurrences in S and the number of occurrences in T of each bigram. Continuing the example, with the help of the hash maps S and T, we can efficiently compute the histogram intersection string kernel between S and T. Doing the computations, we learn that the value of this similarity between S and T is 7. Our second baseline is based on Camembert embeddings. Each document is passed through the Camembert model, obtaining a vectorial representation for the first 512 tokens. We then compute the average of the token embeddings to obtain the representation for each data sample. We use the average Camembert embeddings as input to some linear classifier in the primal form. String kernels provide pairwise similarities between strings. In this case, we apply some linear classifier in the dual form. We note that for the linear kernel, the dual form is equivalent to the primal form. Let's see how our unsupervised domain adaptation method works. First, we concatenate the training data from the source domain with the validation data from the target domain. Then, we apply the kernel trick, obtaining similarities between all pairs of data samples. We take the similarities between source samples and target samples and interpret them as features. With these new features, a classifier can now assign weights that reflect how similar a training sample is with the samples from the target domain, thus adapting to the target domain. We underline that the labels of the target samples are never used in the domain adaptation process. Let's take a look at the experiments. Before going to the results, we should note that we considered two linear classifiers, support vector machines and kernel ridge regression. Our preliminary results showed that kernel ridge regression is better. An important hyperparameter for the presence bit string kernel and the histogram intersection string kernel is the length of n-grams. From our validation experiments, we observed that 7 grams are the most suitable for full news articles. We also used these results to decide which type of string kernel to use in the subsequent experiments. Obviously, the presence bit string kernel is the better choice here. In a similar fashion, we validated the regularization parameter lambda of kernel ridge regression for each type of feature. In this table, we see the results before and after domain adaptation. The results between validation and test are fairly consistent. We observed that Camembert embeddings provide superior results. We also note that our domain adaptation approach brings statistically significant performance gains in 3 of 4 cases. As for the experiments on full news articles, we tuned the hyperparameters on news headlines. Interestingly, we see that the top accuracy rates are now obtained with 3 grams instead of 7 grams. This is likely because the space generated by very long n-grams is too sparse when we work with headlines, which are very short. Similarly, we tune the hyperparameter lambda of ridge regression on the news headlines validation set. Although we reported the accuracy rates above 90% on full news articles, we now see that detecting satire in news headlines is considerably more difficult, the accuracy rates being around 70%. Interestingly, in this difficult setting, the low-level features are more robust, surpassing the Camembert embedding by a large margin. Our unsupervised domain adaptation boosts performance of Camembert by a significant margin, closing the gap with respect to the presence bit string kernel. Let's look at a set of discriminative features. The presence bit string kernel seems to consider vague temporal terms, such as today, this morning, or week, as indicators of satire. Precise temporal references such as Wednesday, Thursday, March are seen as regular news indicators. To find discriminative features for Camembert, we compute the cosine similarity between each token embedding and the weights learned by ridge regression. We employ the same approach for word bigrams. In this table, we see a selection of words relevant for Camembert embeddings. Familiar or informal terms such as grandma and words with funny connotations such as kiss, intercourse, or dummy are seen as satire indicators. When nationalities such as Mexican or Armenian are present, the method tends to believe that the news is regular. In this table, we see a selection of relevant word bigrams. We notice that bigrams for satirical news tend to have a vague meaning. For instance, the term particularly appears recurrently. Another aspect for satirical news is the importance of the features arrondi. This form of the past is more common in novel writing or storytelling. Camembert also found the metaphor black gold as an indicator for satire. Regarding regular news, we again observe references to nationalities such as Carlos the Mexican or North Americans, and references to concrete places or times such as the spring of 2018 as indicators for regular news. Let's draw our conclusions. In this paper, we introduced a novel corpus of French satirical and regular news. We proposed two cross-source satire detection tasks considering full news articles and news headlines. We introduced a novel unsupervised domain adaptation method. By including domain-specific features, we attain statistically significant improvements for both baseline methods. We observed that satire detection on news headlines is significantly more challenging. In future work, we plan to enlarge the corpus and to diversify the tasks. Thank you for your attention. If you find our topic interesting and you would like to use our dataset for your experiments, please read the full paper. You will find the GitHub link where you can download the data as open source for non-commercial use.